So I would like to call upon the panel for the next bit. Let us talk about these three patients and let's see how each one of you do manage these cases. So that next talk is Dr. Jayant, Dr. Praveen, Dr. Nitin Balakrishnan is come, Dr. Ashok Nanda, Dr. Ramurthy. You're going to speak, but still you can moderate this session. The whole idea is we're going to plug in these three patients, and based on all the discussion, you can come on stage. And you can change, you can ask Dr. Pavitra or Pooja to ask whatever. You can come in this side also.
I have no idea what's planned. I mean, you guys have some cases? So, you want to?
Yeah, no, you can be here. The question is, we have this case now with the one diopters which is matching. And so, Dr. Ramurthy, if this is your patient, now how would you treat and what would you do in this patient? That's the question I would ask all of you. So then the audience can get their inputs.
I think, one thing is that we don't attach much importance to the sphere at all. As far as the cylinder is concerned, there's a magnitude and the axis. There is only a mild change in the magnitude. Axis, there's a bit of a difference. I would also, most of the other points were made earlier, but I also emphasize on the fact that not just look at these values alone, but also look at these areas. For example, to some extent, this is going to even compensate for these two. These two is going to potentiate each other, but this is which is at 90 degrees to other one, might even decrease the amount of higher order abrasion that will have an effect on the motocorneal ablation that is required. So this is a case I would definitely go with CONTOURA.
You'll do a CONTOURA, and which axis would you go for?
I would go with 13 degrees.
And do you want to do any changes? I'll finish with him. Do you want to go back and ask your optometrist to shift to that 13 degrees and then see if he's comfortable and then...
I would like to do that at the 13 degrees. And I would like
but if the patient is not happy with that 13 degrees, what would you do?
Then I would, I will shift to this 30 degrees only, 30.
Praveen, what would you do in this case?
First, I need to see whether whether there is a change in the axis by changing the optical zone to 5 mm.
Can you change it to 5 mm?
It remains the same.
It remains the same. So let's go to 6 millimeter here. So anything, which axis would you use? This is the most confusing thing. Which axis would you use? Would you use the 30 degrees or 13 degrees?
30 degrees, the manifest.
Manifest, sir, for you?
Yeah, because the cylinder amount is less than 1.5, I would probably focus more on the acceptance axis, that is 30.
Dr. Nitin?
Cylinder is high, then probably the question arises.
No, but there is a difference of around 15 degrees here.
The conventional teaching is if there's a huge amount of difference in the cylinder, more than
15 degrees.
15 degrees when the magnitude of cylinder is less than minus 1.75, that's when you go ahead with the measure. Here, since the amount of cylinder itself is quite less, I would rather take the advantage of the measure rather than what the patient's acceptance is.
I would re-refract. I would have the patient re-refracted, and to check whether the refraction was right. The second thing is whether the patient would accept a cylinder at about 15 degrees or so. At about 15 degrees. If the patient doesn't accept the cylinder at 15 degrees on re-refraction, then probably I would treat as per the manifest refraction.
That's what he
That's
said.
30.
Dr. Jayant?
Yeah, if he doesn't accept this cylinder, again, I also do the same, that we re-refract, and if the patient still doesn't accept emphatically, then I would definitely do it at 30 degrees.
Anybody else here has?
Sir, I just
I would also go by the 13 degree axis only, topographic.
Okay.
Sir, can we see the topography of this patient?
At this point, I don't know. I don't think so we
On
have.
any other machine?
Why do you all say 30 degrees then?
Topography is perfectly healthy. There's no sign of any suspicion. I know why you are asking that. More than the topography, probably Zernike pyramid would really help in this patient, because that is where...
Can you see the Zernike polynomial for this patient?
Go to Zernike polynomial there. So C4 is 0, C12, C7 is little on the higher side. But C8 is on the, this is C8 is a more higher side.
C8 and C9 both are
higher. So it's more of coma related.
Yeah.
So what you are saying is right. The cystosis in this case, looking at the C9 being higher, and with so much of Dr. Ramurthy pointed out, you go for a 30 degrees or 13 degrees.
I mean, just looked at the Fourier analysis to see what the axis does, and the axis swings from 15 to 30 over there in the Fourier. So there is a change.
Can you plug that?
In the axis already at the anterior corneal level. So therefore I switched it back and forth.
So technically 13 degree would be better.
Exactly. There was also a good point here from Dr. Gekle that he made. Maybe this helps.
I just say, you see, a subjective refraction is just a subjective impression of what the patient thinks is good. And when we give more different axes, maybe the patient feels to have a little bit more of contrast or so, but it still remains something subjective. And me personally, I always trust completely the CONTOURA cylinder and axis, because I don't give nothing on the subjective refraction.
So you go only by the CONTOURA cylinder. See, one of the interesting things here is when you don't match, like I said, CONTOURA is not a no-brainer procedure. You need to spend some time when you have these kind of problems, because one of the most important rule here is that when you keep it 0, then you get the right picture whether CONTOURA is working in this patient or not. And Dr. Ramurthy sir showed very nicely, even though the values are small, there's still a lot of coma being treated. So when you see that a lot of coma is treated, that means that coma is there in this patient. Then Dr. Nitin also said very nicely that you go to Zernike and go to Zernike map and you click on the Zernike and you can see that the C9 and these factors are really on the higher side, which means that the patient has coma which is there. So that the machine's axis is driven by what your dominant factor is, and that is one of the reasons why the machine is showing us a 13 degrees. Am I right? So in this patient, I would go by the axis of the machine, because you know that there is some issue out there.
Exactly.
Can you just take this off?
Do we have to popularize the picture for the Fourier analysis for this patient?
They're trying to connect, they should be able to connect.
The problem with this amount of high order aberrations is, or the Zernike polynomials, it tells you the amount, but it doesn't tell you the slope. And you imagine if I have a mountain that high, the mountain can go slow, right? Or the mountain can go very deep and hard. And what we have here is a deep and hard dive from this area here. And especially if we go through here, you see that? It's right in the middle of his pupil.
Can you get the Fourier?
Yeah, you see that? If I put...
Basically that means that...
Why do you say you'll go with 30? Why do you say you'll go with 30 in this?
No, I would go with 13.
13.
Yeah, 13, right.
Yeah.
1-3.
1-3. My understanding was that...
Sorry, go ahead.
No, my understanding was that both the cylinders were matching. If the cylinders were not matching, then I would have gone for the coma component and the cylinder of the...
So what happens is when your component is very small, the coma it's very, when your cylinder component is small, they match very well. Only the axis changes. What happens is in that axis, what you have measured, the axis was 13, but probably if the pupil increases like I just showed, the axis may be something else. So, but one of the take-home points is if you go back to this 0 rule and you see that a lot of aberrations are there, and you go to the Zernike pyramid there, and you feel there's aberrations that go more towards the topolyser axis.
I think this is a kind of case which would typically benefit from a CONTOURA treatment.
Yes.
You know? The astigmatism is not too high. The amount of magnitude is almost matching. There's only a slight shift in the axis, and the shift in axis is also not very much. And I think this is a case classically where I would go with the measured axis rather than what the patient is accepting. In case if you don't, in this case you're going to be treating with 30 degrees, then that means you don't believe in Contoura.
Contoura, exactly.
That means you're just going to stick to wavefront optimized.
We don't need this. We don't need this. Go back to this one. Go back to the second case where the second time, 13. 1-3. Even though it's scary that you know that you're treating an axis which is not what the patient accepts, but based on the first talk we gave, patient cannot accept that axis because it's a higher order aberrations. And even if you go back, ask your optometrist to re-refract, you will not get 13. You'll get 30 only because the patient. And in this case, sir, now again, it's a second group. The second group is there is a 1.5 diopters of change. The patient acceptance is 2.25. What the machine measured is 3.87. The axis is bang on now. It's only 5 degrees change. So now if you go back to that zero rule, you have a huge amount of aberration. We'll try to get the topolizer connected so that we can show the Fourier a little later. But I'll start with Dr. Nitin again. How would you treat this? You can just tell
I will first see the Zernike. The Zernike first.
Yes. So you know that there is all the aberrations are on the higher side. C9 is very...
C7 also.
C7 is 3.
Yeah.
So what are you specifically looking for in Zernike here?
Coma.
I'm looking for coma, I'm looking for trefoil. So
just look at the topography.
Yeah, but whether it's significant or no, whether what's
on
happening over there.
He's trying to show because we don't have the pyramid, right? So he's just... So machine is actually treating high level of C7, which is coma, right, Sisimosis? And that is around 3, which is quite high compared to what we normally see. And you have a high level of... now, with this in mind, the Contoura really works. This is a real litmus test to see that Contoura works, even though there is close-it. Even you can see there's so much of difference. Now, what would you plug into the machine and how much would you do?
The axis, I would go in as per the measured axis.
You can write the axis as 6.
6 degrees. In this case, I'll split the cylinder into, I'll go midway between the 2 cylinders.
So you do a mean of 2?
Do a mean of 2.
So if you take a mean of 2.25 and minus 3.87, let's assume 3.25.
Approximately. And
so write 3.25.
Since I'm overcorrecting the cylinder by a diopter, I would undercorrect the sphere by half a diopter.
So you would give us minus 1.
Now on minus 1, I would apply the nomogram.
Okay, let's assume this is nomogram based. On minus 1, there's not, I don't think there's much nomogram come.
Overcorrect by quarter.
Yeah.
0.2. I think it should be plus 0.5.
Yeah. Dr. Ramurthy, how would you approach this? Keep it 0 again.
See, if you go by the classical teaching of how Contoura is to be done, you should just simply go with 3.87 with 6 degrees because and then of course make a compensation for the spherical error. Take half the amount of the difference between 3.87.
That's your TMR. You're talking about TMR.
That's the TMR. That's what John Canelopoulos studies.
So can you just show what TMR is? So keep 3.87. Dr. Ramurthy is going to explain about the TMR, the topography modified refraction. And now, how much do you change, sir?
Half the difference between these two.
Half is 1.25, that becomes 0.75. So you have to take 0.75 off. Yes. And with the nomogram, yes, 1. This is Dr. Ramurthy's way of doing a TMR. Anybody has doubts, questions on this?
I would consider the ablation of 12 microns because of this topo-guided thing. That's why I would not treat this in 3.87. I will slightly reduce this.
Maybe 3.5 you would keep.
3.25 or something.
Yeah. Do we have the pentacam? Do we have a pentacam or posterior astigmatism of this patient?
All this is normal. These patients, I don't have it, but I can show it to you.
It would be interesting because I think we have to consider the posterior. If it's low amount of posterior, low amount of astigmatism, posterior doesn't play a role. It's 0.1, 0.2 diopters. But I assume for anterior 3.87, the posterior will be in the range of 0.6. So I would go rather to your way because I say, okay, wait a minute, this is the full power. John Canelopoulos had good results with it. But I think it's visceral astigmatism. We need to look at the posterior. It's going to be a bit reduced by the posterior surface. And it might become a little bit important now since we are at 4 diopters. Yeah? So I do agree with John Canelobos, but John is also looking at, hey, wait a minute, this is a 3.4 diopters. Wait a minute, what is my posterior? And here the posterior can play a role. So he would go half a diopter less.
Exactly.
Maybe even I would think of keeping it at 3 diopter of astigmatism.
So
with a rule, I mean, if you keep a little bit, a quarter or a half, if you don't flip his axis, he's not going to be extremely unhappy. So you have two approaches. Either you go now and you go back into your pentacam or Cyrus, and you look, okay, how much is the posterior? And say, okay, it's not very precise though. Okay, don't believe the numbers of the posterior that they're precise. But if you see that they're 0.6, 0.7, why not to back up a little bit? Then back off another little bit because it's with the rule. So then I would be rather with you 325 at 6 degrees and would feel very well. So interesting would be also what the 4 CDs would be do.
I think as I mentioned...
No, you are presenting that 4 CDs.
Yeah, 4 CDs. Yeah. But as I mentioned, all these are options. Actually, I would say that none of us are wrong, and different patients, different things will work. Simply because CONTOURA, TMR, half the difference, all these things are based entirely on the anterior corneal surface. That's where the error comes in. And when you start considering other layers, then there is a compromise, and you can't say dogmatically that these are the numbers, so this is what I will do.
And Praveen, you would change anything differently?
What if we treat in the manifest refraction based, like the spherical with 1.5 and the cylinder remaining at 2.25?
That becomes your wavefront optimized. But
and just changing the cylinder axis?
No, because then you will not be giving the patient the benefit of a true cylinder. That's what the whole talk in the beginning was. What is your true cylinder, which includes the aberration and your posterior corneal astigmatism? Let's assume that here it is now.
Let me express it a little bit different. If you would do now the manifest refraction, the 225, and with 6 degrees, okay, or 180, what you most probably would have is -1 astigmatism with a new axis because you removed his high order aberrations, you didn't treat the cylinder where it was, and now you have a new induced cylinder. So this is the danger if you do the measured astigmatism and power and axis. And by the way, the paper from Avi Wallenstein that you refer with, if you, there's a little bit of stuff there to look exactly what he did. He selected a certain group of patients. This is not the total group. It's 25 degrees to 160 and a certain amount of difference. And this is actually those patients that refer to group number 3.
And yes, Dr.
But what Dr. Praveen said is basically what the original FDA protocol was. So the original FDA protocol was doing it at the
one care. The FDA protocol was with patients and cornea that had no higher order aberrations. There's been selected corneas where the difference between the manifest and measured was almost known. And this is the interesting portion that I would like you to take with you as information. We did treat patients with no higher order aberrations or low amount of higher order aberrations, but the patients gained line and vision.
So that means these patients on whom you did an FDA trial would have benefited even without an CONTOURA.
And this is exactly the interesting thing. They should have, even if you would have treated with CONTOURA, they should have come equally well out, but they did.
Yes.
They did come better out. This shows also that there's something more into topography guided, and this is something that I would like to pay attention. Topography guided is not wavefront optimized, period. Topography guided, even with the same power, with the same astigmatism, and with low order aberration, does a better job than any wavefront optimized or custom Q treatment. Why? Because we have something that is called a correction matrix. This correction matrix calculates the amount of pulses to not lose energy from center to the periphery, plus biomechanical changes plus epithelial remodeling. So what I'm telling you is, if you do topography guided, even though you have no higher order aberrations, the ablation profile and the correction matrix is exactly adjusted for this eye. Even with no higher order aberrations, you will have better surface, corneal surface afterwards, and you will have a better epithelialization or epithelialization, and we are taking this into account. Please keep this in mind, because we're discussing all the time, what should I take it, and do I have a high amount of high order aberration? Is this going to benefit? No, forget this. This is the sherry of the cake. The most important part that you need to understand about topography guided is that we take the real surface of the cornea and we put a myopic correction matrix on how much power we need to deliver, what the postoperative curvature should be to have the best treatment for a -7 with a -1, and there included is the epithelial reaction and the biomechanical change, okay? Don't forget this, please.
Yeah, based on what you said, what I understand is for patients who have their refraction and measured equal cylinder, both in quantity as well as in axis, if you did a CONTOURA versus if you did just a wavefront optimized, Dr. Rohit said that the results were probably going to be equal, that the CONTOURA may not have a value addition, but you differed, saying that the outcomes of the CONTOURA is better. Is that what I gather? So what is actually better? What was better? Was it from the patient outcome viewpoint, or was it from the corneal topography viewpoint? What is it that you applied to say that the CONTOURA worked better in cases where both were the same?
The FDA results, because we had exactly those patients from 0 to 9 diopters, from 0 to 3 diopters of astigmatism, with no higher order aberrations. The patients that we treated in FDA study have been patients where they had no significant amount of higher order aberrations because the manifest and the measure was checked preoperatively, and only patients have been allowed to enter the surgery or the treatment that they had no big difference. What I can tell you as a company from the manufacturing point of view is that wavefront optimization is a correction matrix that takes in, and this is published. Michael Mrochen, Seiler, Christoph Donetsky, you know this paper. And there you can see that we are not taking only the angle of incidence in consideration. There's also biomechanical change there in the epithelial remodeling. So if you have wavefront optimized, for the wavefront optimized takes a certain K readings in consideration and a certain refraction in consideration. That's it. With topography guided, you take the asphericity in consideration, the exact height and elevation in consideration, and you customize your ablation profile and your reaction on it. So you can't compare wavefront optimized.
And Dr. Radhika, to answer your question, I'm trying to just get a paper. We published this paper before they named it as CONTOURA, but just named it as CONTOURA. One eye, those people who matched, it was in JRS. We did the one eye was on CONTOURA, the other eye was based on quantity of vision, they were the same. But when we looked them, pushed them to a little bit more, those things will be discussed over the next 2-3 hours. They had a better quality of vision as far as those aberrations were concerned. In fact, what he's trying to say is when you use the matrix, you don't induce unwanted aberrations, which gives you the dampening of your quality of vision. So that's one of the reasons in these kind of patients, earlier thought process was just ignore it, go back to wavefront optimize. The patient may come back to you tomorrow seeing 20/20, but he may have just a 0.75 or 0.5 cylinder. That 0.5 cylinder is filled with all kinds of unwanted commensal separations. So that will not going to be very happy, especially if he's a computer user, because he'll not have a depth of focus. And if you don't have depth of focus, they keep having headache, strain, migraine, night vision problems, multiple things out here. So that is the answer. And here, to sum up on this particular case, the best approach is what just don't go too much into this 3.8 because we don't know, maybe 3.25, 3.5. That 0.5 we really don't know, and just adjust it with your spherical. And because there is so much of a higher order aberrations out here. And going to the zero rule, and like Dr. Nitin said, going to Zernike is a must in CONTOURA treatment. Yes, Ritin?
Sir, any of the panelists, I just had one small question. If you look at the zero ablation profile, it's about 12 diopters in the periphery and about 6 microns in the center. This is going to have a net effect of about 0.5 diopters of hyperopia. Would we adjust that? The C4, C12 is what I'm talking about here.
See, I think that's the reason why Dr. Jayant Sarwate said that don't go 2 into 3.8, just go into 3.5, 3.25, because he's factoring that. I also factor it because that 0.25 or 0.5 which is offset can be factored in. Basically, CONTOURA is really fun if you know how to use it. In fact, it's once you start using it, it really makes your job really interesting. It does not become your routine refractive surgery. You go look into this, look what you are trying to see. It makes your practice more interesting. In fact, I can get the same 20/20, and all the surgeons here are much more experienced and better than me. They can also get it better. But the challenge here is that fun you lose when you are actually doing just a wavefront optimized. And you are getting data. This paper is what which talks about the difference of quality of vision in these things.
I think we must have some definite guidelines as to when we switch over completely, when we don't. And
I think we have something planned for this evening.
Okay. No, why I'm saying is that I found some of the decisions a little arbitrary in the sense that the FDA trial did show that CONTOURA works, and they had specific limitations as to when to apply it, when not to. And if you go by that guidelines, the difference of 1.25, 1.5 is
Then we
still
have to do wavefront optimize for all of them.
Sorry?
Then we have to do wavefront optimize for a lot of them.
And basically, just to answer your question, I think CONTOURA at the end of the day gives you excellent anterior corneal topography, but that doesn't necessarily translate into excellent vision for the patient.